We're going to continue to look at quadratic functions. Now we've looked at quadratic functions kind of in the standard form of something times x squared plus a number times x plus another number. We're going to look at quadratic functions that are in this form here, referred to as your vertex form. We have something times in parentheses x minus h all squared plus k, where h and k is representing our vertex. Now, remember, your axis of symmetry goes through the vertex, and it's x equals the x-coordinate of your vertex. Well, here our x-coordinate of our vertex is h, so our axis of symmetry is x equals whatever the value of h is. Now, on the following parabolas, we want to figure out how we are translated compared to our basic y equals x squared graph. We want to find our vertex, axis of symmetry, and direction of opening. So as we look at this one here, our vertex, according to this, is hk. It's the opposite of what's in the parentheses. So that's going to be then a positive 3, and the same as what's outside of the parentheses. So that means our parabola is translated 3 units to the right and 2 units up compared to our basic parabola that goes to the origin. Our axis of symmetry then is always x equals the x-coordinate of our vertex. Since the number in front of our parentheses is positive, we know we're opening up. Now, when you're making your graph, you can always go ahead and make a t-chart. You could put x equals 3 here, and then try 2 to 3 numbers on each side of your vertex, and we talked about how we can use our calculator to make that t-chart. Now, there is a slightly easier way to do that. It's following this pattern here. Over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7. In other words, we're going up by the odd integers. So I'll show you how that shows up on your graph. You go to your vertex, then you go over 1, up 1, over 1, up 3, over 1, up 5, which would be way off of our graph. And then you do that the other way from your vertex, because remember, it's symmetrical about the y equals x line, or not y equals x, but the axis of symmetry, in this case, x equals 3. So over 1, up 1, over 1, up 3, then it would be over 1 and up 5 more. Now, this pattern works great, but keep in mind, if there's a number in front of your parentheses, you really have to multiply this pattern here in red by that number. So you go over 1 up 3, over 1 up, in this case 9, over 1 up 15, and then over 1 up 27. So whatever number is in front, you multiply that by these red numbers here, and that tells you how much to go up. So we need to go ahead and get this function that's in standard form into the vertex form. And we want to do that by completing the square. And there's really 2 different ways to do it. I'll show you both ways. I don't really care which way you do it. Use the method that you prefer. Now, if we complete the square like we've done before, we need to get the number in front of your x squared to be 1, which it is. Then we're trying to complete the square with the x's, so we need to get our variables by themselves. So we want to subtract the 4 over, and we get this. Well, then you have to take half of b and square it. Well, half of 2 is 1, and then you got to square that, and 1 squared is 1. And if I add it to the right, I'd also have to add it to the left, because what I do to one side, I got to do to the other side. Then we'd want to factor the right side. It's going to factor into 2 parentheses that are both the same, of an x plus 1 and an x plus 1, or we can write it as an x plus 1 all squared. Now remember, we had said the shortcut is whatever's being squared here goes in the beginning. Whatever is being squared here goes in the end. Now this minus 3 comes from the negative 4 and the 1. Then we just have to go ahead and get y by itself, so we can add 3 to both sides. We now have it in the vertex form, where we could easily identify our vertex, our axis of symmetry, and our opening. Now, a second way you could do completing the square. Instead of taking stuff to the other side, you could keep everything on one side. So we're going to just go ahead and make sure we get a 1 in front of our x squared, which it is. We're going to group the x's together, and we're going to complete the square with the x's. So I'm going to go ahead and put a space after my x so that I can add something. Now I got to take half of 2 and square it. So half of 2 and square it is 1 squared, or 1. Now if I add something on the right side, I would then have to subtract it on the right side, because then I would have a net change of 0, because I'm just doing stuff to the same side. So then I'm going to have to subtract this 1 here times this red 1 squared here. Now, a second way you could have thought of it is, if I added something here, I'd have to add it over here. But if I added it over here and I want y by itself, I'd have to subtract it back over. So it's another reason you can look at it to understand why we're subtracting this. So the parentheses will factor, we simplify what's afterwards, and we get the same vertex form. Now, to find our vertex, it's the opposite of what's in the parentheses, same as what's on the outside. Axis of symmetry is always x equals your x coordinate, and because we have a positive 1 in front, we are opening up. So we could go to our vertex, 1 to the left and 3 up, and then we could use that pattern of over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7 to help us graph, or we could go ahead and make a t-chart and or have our calculator make the t-chart for us. So we plot our vertex, 1 to the left, up 3. Then we go over 1, up 1, over 1, up 3 more, and then over 1, up 1, over 1, up 3 more, and we can get a rough shape of what our graph will look like. So go ahead and try to complete the square on your own for this one, and then follow the video to see if you agree with it. Get the number in front of your square term to be 1 by dividing everything by 3. And then we get this. Get your x's on one side by itself by adding 3 or 4/3 to both sides. Then we can actually complete the square. Now on the left side, I'm going to just write it as one big fraction. The right side, we can go ahead and complete the square. So we'd have to take half the 2 and square it. So we'd be adding 1 to both sides. So the right side, we get this. The left side, we get a plus 7 here, because remember, we're over 3. 1 is 3 over 3. So 3 over 3 onto this 4 over 3 is where the 7 comes from. Then we need to go ahead and get y by itself. So I'd want to multiply both sides by 3. I'd want to subtract the 7. And then I'd have to get rid of the negative by dividing both sides by -1 or multiplying both sides by -1. And I would get this. Now, what's it look like if you use the other method where you keep everything on one side by itself? You want the number in front of your squared term to be 1. So I'm going to take a -3 out of just the x's. Now we've got to complete the square with our x's after we take that -3 out. So I'd have to take half of 2 and square it, and that tells me what I'm going to add. So I'm going to put a plus 1 here. And remember, if I add it here, I have to subtract it here. So I have a minus, but it's really a -3 times that 1 squared is what I put there. So I need to subtract that -3 times 1 squared. A second way you could have thought of it, if I added a 1 squared here that's multiplied by -3, I'd have to add it over here. But to undo that, you'd have to subtract it back over. Now, we get y equals, we're going to have a -3 in front. We're going to have that x plus 1 here. Well, let's see. This is just a 1. 1 times -3 is -3. We get 7 minus a -3, or 4 minus a -3, so we get 7. So you get the same answer either way. My preference is for the blue because I'm lazy and it requires me to write less. But I would encourage you to use whichever method you understand and that you're comfortable with. Your vertex, opposite of what's in the parentheses, same as what's on the outside. We're opening down because we have a negative in front. Our axis of symmetry would be x equals our x coordinate. So we can graph our point. 1 to the left, 7 up. Now, normally we go over 1, up 1, but we got to remember to multiply what we have in front by that pattern. So we're going to go over 1, and then we got to go 1 times that -3, which is -3, so we got to go down 3. Then we normally go over 1 and go up 3, but we got to take that 3 multiplied by what's in front, and that's a -3. -3 times 3 is -9. So then we got to go down 9, and then we'd have to repeat that pattern. But in this case, it would be way off our graph. But it allows us to be able to get our basic shape of our graph. Or you could always make yourself a T-chart, starting at your vertex and choosing 3 numbers on each side of your vertex. This one here, we're kind of working backwards. For the most part, we're given our vertex, and I'm not sure what happened to the rest of my word up here. Sorry about that. And my computer's not working right, so I can't go ahead and fix that. So I'll have to figure out that. So just a sec. There it came back. I'm not sure what happened there. But we have our vertex. So I'm going to start out with my vertex. I'm going to plug my h being -1 in, and my k being that 4, because my vertex is hk. So if I plug in -1 here and 4 here, that gives me this. I know it passes through this point. Well, that means my 2 is my x, and my y is my 1. That allows me then to be able to figure out what a is, because if I plug in my 2 right here and my 1 right here, I have then just one equation. I can go ahead and solve for a. So simplifying this down, I can get a 3 squared here, which gives me a 9a. Subtract my 4 from both sides, divide by the 9, and I get -1/3. So all I'm going to do is rewrite this right here with the correct value of a in it, and that means I'll be done with this problem.